Hello everyone, this is Alistair here, and today's problem of the day is titled Queue using two stacks. So let's have a look at the problem itself. So the problem asks us to implement a queue, but the catch here is that you have to implement the push and pop operations by using two stacks, that is S1 and S2. And here are certain operations that you are given, one which represents a push operation and two represents a pop operation. But we need not worry about that since we are simply asked to push the elements and pop the elements and not consider the queries individually. So let's have a look as to how we can perform the operation. Before moving on, let's understand what are the operations that we have to perform on the queue. Since queue is a FIFO data structure, meaning it works on first in first out approach. Whenever we push a element, it is pushed onto the queue and the upcoming elements are then pushed in simultaneously. And whenever if we have to pop the element, we will be popping the first element that has entered the queue, and we'll pop this, then the next element that has entered is 8, will pop this. So this is how a queue works. Now in order to implement a queue using two stacks, there are three ways of doing so. uh, First way is by making the push operation expensive, and which would make my pop operation in to operate in O of one time. The second way is to make the pop operation expensive. So the first way is to make the push operation expensive, and the second one is to make the pop operation expensive. Doing the push operation expensive, it will make our pop operation to work in O of one time. And doing this, that is making a pop operation expensive, it will make our push operation work in O of one time. So you could go either way about the problem. And there's also another approach wherein we can use only one stack and use another stack as our, that is our function call stack, to implement a queue. This simply means that we will be using a recursive approach for creating a queue and implementing the push and pop operations. So since we are specifically asked to use two stacks, that is the stack S1 and S2, we'll be focusing on how we can go about these two approaches. So the first approach, that is making our push operation expensive, which would result in making our pop operation work in over one time. Let's consider the example of the queue, which has the values 2, 4, 6, 8, and where 2 is the first element that has been pushed and 8 represents the end. Now let's take in two stacks, that is S1 and other stack S2. So since I have to make my pop operation inexpensive, it means that the first element of the queue, that is 2, has to be available to me every time I perform this pop operation. And this is only possible if this 2 is present at the top of the stack. So let's first write all the queue elements on this S1, on the stack S1, such that Q is present at the top and will maintain the order of the queue. So it would be like this: 2, 4, 6, 8. Alright. Now whenever I perform pop, I'll always have the first element that has been entered into the queue available to me, and I can pop it in O of one time from the stack. Now what if I want to push a new element? So for example, I have to push 9 over here. In that case, 9 has to somehow come to the bottom of the stack, right? It has to be present before 8. For that, what we'll do is we'll simply pop all the elements from S1 and push it into S2 till our S1 becomes empty. Doing this, we'll get 2, 4, 6, 8 as our elements in S2. And after doing this, our S1 will become empty. And after our S1 becomes empty, we'll simply push 9 onto the stack S1, and will again then pop all the elements from S2 and put it back inside S1. So we'll get 9, 8, 6, 4 and 2. In this way we'll never lose our first element that has been pushed onto the queue, and we'll always have its access whenever we are required to perform the pop operation. Now let's have a look at the second approach, which involves making our pop operation expensive, which would result in my push operation to operate in O of one time. So the only way we can make our push operation operate in one time is by simply pushing all the elements that has been requested to be pushed onto the queue onto the stack S1. So let's consider an example queue. We have our first element that we have to push, that is 2, that first element uh, at the start of the queue, that is 4. Then we have 2, then 4, then 8, 9 and so on. Here 2 is the beginning of the queue. We have our 2 stacks S1 and S2. Now since we are performing this operation in one time, we'll simply push 2 as it comes, then 4, then 8, then 9, then 7. Now I have to perform pop operation, and pop operation should give me the value 2 since it was the first element that was pushed into the queue. But this 2 is present at the bottom of S1 and stack does not allow me to access it. So what I'll do is I'll simply pop all the elements from S1 till my S1 becomes empty and push them onto S2. So I'll pop 7, push it onto S2, pop 9 from S1, push it onto S2, pop 8 from S2, pop 8 from S1, push it onto S2, pop 4 from S1, push it here and simply push 2 also. After doing this, my S1 stack will become empty, and after my S1 stack is empty, I can simply pop the top of the stack S2. On popping, I'll always have the element that has been pushed first available at my S2. Now in order to make it more efficient and not to go back and forth about pushing all the elements from S2 to S1, just to maintain the queue order, what I can do is I can keep a check onto if my S1 is empty, S2 is empty or not. Since I've already pushed all these elements, let's perform some operations like pop. On popping the element, I'll check if my S2 is empty. Since my S2 is not empty, which means that I have my access to my first element that has been pushed onto the queue. So I'll pop 2 over here. Now whenever a new push operation comes in, for example I have to push 9, I'll simply push it onto stack S1. Then if I had to perform another pop, I'll simply check if my S2 is empty or not. Since it's not empty, which means that I have my access to the first element that has been pushed onto the queue, that is 4. So I'll pop 4. Now I'll again perform another pop, which would remove 8 elements since S2 is not empty. Then I'll again perform another pop, which would remove 9, and another pop, which would remove 7. On doing this, my stack will get empty. Now for example, if I had to perform another pop, then we'll again consult our S2, but in this case our S2 is empty. That means I have to consult the stack S1, and if my stack S1 was also empty, it means that there are no other elements present in the stack S1, no other elements present in the queue itself. In that case, we'll simply return -1. Since it is not the case since we have already one element present in S1, what we'll do is we'll simply pop this element 9 and push it onto S2. Doing this, it will leave our S1 empty, and then we'll return the value 9 which is present on S2 since it was requested by a pop operation. and after doing that, our both S2 and S1 becomes empty. So in this way, we can handle the push and pop operations much more. Now let's move on to the code itself. So since we are making our push operations, we'll be considering the uh, second approach to go over the problem, that is making a pop operation expensive and push inexpensive. So since a push is inexpensive, which means we simply have to push all the elements that has been pushed to the queue onto the stack S1. So I'll do this. Now coming to the POW operation, which is our expensive operation, meaning it works in O of n time, we'll simply have a check first. We'll check if our S1 is empty or not, and we'll also check if our S2 is empty. This is because both our stacks can be empty, and if that is the case, we'll simply return -1, meaning there are no elements that are present in the queue. And then we'll check if our S2 is empty. If that is the case, what we'll do is we'll simply uh, perform a while operation on till our S1 stack becomes empty. So we'll do this till our S1 is empty, and we'll pop all the elements from S1 and push it onto S2. So we'll push onto S2, take in the top value pointed by S1, and then we'll pop the top value from S1. After doing this, there are no other base cases to be handled, since one of the case could be that there are elements present over here. We have checked if S2 is empty. We have also checked if S1 is empty, and if both are empty. Now the only case remaining is that if our S2 is not empty, and then in that case we'll simply return the top of the stack S2. So in order to handle that, we'll create a variable, take the top value pointed by S2, and simply pop the S2 value and return the result as it is. Yeah, let's try and compile. Yep. Alright. So that was it for today's video. If you have any doubts, you can ask them in the comment section, and thanks for watching.